Good morning, class. We are looking at Chapter 8, Application of Trigonometric Functions. This is 8.2, the law of cosine. So we are going to move on from here. We covered the law of sines. We are going to cover the law of cosines, and the objectives are to solve SAS, side angle, side triangles, solve SSS, three sides triangles, and solve applied problems. Trig identities, we've seen many of them, so fundamental identities, even and odd properties, periodic functions. All trigonometric functions are periodic with the period of 2 pi, except tangent and cotangent. Pythagorean identity, sine squared plus cosine squared is 1, and the rest of them. Quotient identities, tan theta is sine over cosine. Cotangent is cosine over sine. Reciprocal identities, cosecant is 1 over sine, and the rest of them. Sum and difference formulas, sine of alpha plus beta is sine alpha, cosine beta plus cosine alpha, sine beta, and the rest of them. As we can see, there are many identities we should be comfortable with. Double angles such as sine to alpha is 2 sine alpha cosine alpha. And these are other summaries that we see here for sine squared alpha and sine squared of alpha over 2, which results in sine of alpha over 2. Now, just again, for the sake of argument, this one will result in this. If you solve for sine squared alpha, this one will result in this. Okay, and as long as you have these two, cutting the alpha in 2 works out, and tangent is the ratio of sine over cosine, so tan squared is the ratio of sine squared over cosine squared, and so on. Product to sum and sum to product, sine alpha, sine beta. These are some of the identities that you may come across. The ones that I highly recommend. If you know those, you can create and prove these as well as this. Okay. In the case of a right triangle, you know a squared plus b squared equals c squared by Pythagorean theorem. And of course, the angles A and B must add up to 90 degrees. We have one 90-degree angle. The other two are acute, and they add up accordingly. And with that being the case, sine is defined as opposite over the hypotenuse. For example, if this is theta, sine of theta is going to be the opposite b over the hypotenuse c, and cosine will be the adjacent a over the hypotenuse c, and the rest of it. And we also discussed the angle of elevation. So here's the horizontal line. If you're looking up, the angle of elevation is created. Looking down, the angle of depression. As far as the bearing is concerned, there are 2 ways. Method 1, you just deal with up north and you go clockwise. So any angle. So simply put, you just mention the degree with respect to the top. Okay. For example, this one has this angle 300 degrees. That's all you have to say. However, if you and so in the second case, method 2, you start with either north or south first. Okay. In this case, P1, for example, you start with north. and it's going 30 degrees east. But if you're looking at P sub 3, you start with north, it's going 70 degrees west. If you're looking at P2, it's south first, and it's 50 degrees west. For example, P4 would be south 20 degrees east. The law of sine, we look at the law of sine as sine A over A equals sine B over B equals sine C over C, and we have various cases, ASA, SAA, SSA, SAS, SSS, and as you know, S stands for side, A stands for angle. So ASA or angle, side, side, so on and so forth. One side and two angles result in one unique solution and one unique triangle. SSA, side angle, two sides and an angle, opposite one of them could result in several different situations and solution to occur. Consequently, SSA is referred to an ambiguous case. So we may end up with this case. If A equals H, we end up with the right triangle. If A is larger than B, larger than H, one triangle. If A is obtuse and A is larger than B, one triangle. In this case, if A is acute and A is less than H, there is no triangle. If A is obtuse and equal to B, no triangle. And in this case, when H is less than A and A is less than B, then we end up with two triangles in that case. And we have case 4, SAS, side, angle, side, two sides, and the included angle does have a unique solution. And finally, all sides are given. Three sides result in one unique solution and one unique triangle, as long as one side is smaller than the sum of the other two. And this requires cosine. So let's move on to the cosine law. And this one could be done in some instances by sine law, and in some instances we use the law of cosine. All right. So in this case, so side, angle, side, and side, side. We are going to require the cosine law for the last one. So what is the cosine law? This one is important to know. There is no solution if one side, for example, A, is larger than or equal to B plus C. So if it's equal to B plus C or it's larger than or equal to B plus C, can't have a solution. One side larger than or equal to sum of the other two sides. That's the concept. In other words, if you look at the following drawing, everybody, if you look at, let's call this A, B, C, each one of the side must be, for example, C must be less than the sum of A plus B, because the closest distance is a straight line. And that makes sense. Otherwise, if, for example, C is equal to A plus B, then there is no triangle. That's the concept. These are the cosine laws. For one of them, for example, A squared is B squared plus C squared minus 2BC cosine A. This is the included angle. B squared is A squared plus C squared minus 2AC cosine B. C squared is A squared plus B squared minus 2AB cosine C. This is cosine. And so with that being the case, if you want to solve for cosine, I can move this one to the other side. Okay, so this one I want to show you. Let me show you right here. If I move this one, I get 2BC cosine A. The right side is B squared plus C squared. And the A squared, I move it. Now notice, if I do that, I can find the cosine A. Okay, so that's a proof of that. And here's the interesting part. Pay attention to this. The law of cosine generalizes the Pythagorean theorem, which holds only for right triangle. Think about this. If A is 90 degrees, cosine of A is 0. This becomes 0, A squared equals B squared plus C squared. So this works for any angle. If the angle is 90 degrees, it becomes Pythagorean theorem. That's the concept, everybody. That's the concept that we are discussing. Let us look at the proof here. So we have a triangle ABC. Therefore, opposite capital A is lowercase a, opposite capital B is lowercase b, opposite capital C is lowercase c. So this whole thing, AB, is lowercase c. So if we drop a perpendicular and we have the height or the altitude h, if this distance, we call it x, the total distance AB is lowercase c, then BD is c minus x. So this is AD, this is BD. That's the concept. When we drop a perpendicular, it creates two triangles. One of them is ADC. If you look at this one, Pythagorean theorem says this side, AD squared plus CD squared. That means x squared plus h squared is AC squared or B squared. So this is x, this whole thing is C, this is C minus x, right? X squared plus h squared is B squared. So let me write that in case anybody has any problem with that. So what we are saying is that AD squared plus CD squared equals AC squared. So in this triangle. Also, this angle is a cosine. A is the adjacent x over the hypotenuse b. And therefore, x is the product of these two. Product of these two. Okay. In this one, the right side is also a right triangle. And I can write BD squared plus CD squared equals BC squared, Pythagorean theorem, right? So BD, C minus X, CD, H, and this is A. So we have this one, okay? We are going to square this, C squared minus 2CX plus X squared, and we write the rest of them. So we square this, C squared minus 2CX plus X squared. Now, notice from up here, x squared and h squared, I can replace this with the b, and x, I can replace it with b cosine a. So this This one, I can replace it with this, and x, I can replace it with b cosine A. So I have c squared minus 2c times b cosine A, and over here, I'm going to have b squared. So that's exactly what we are claiming. A squared is b squared plus c squared minus 2bc cosine A. That's all we are claiming, and we just proved that. So it's pretty straightforward. We are going to move on. We are going to look at this very simple example. We want to solve this SAS where C is 60 degrees, A is 2 opposite the capital A, and B opposite the capital B is 3. Well, if we look at this formula, we're going to apply this to C. I want to make sure that we understand how that thing works. So if I change this to C, so this becomes C squared, and it becomes A squared plus B squared minus 2AB cosine C. I hope you can go from here to here. I hope you can make the transition. If you memorize this, A squared is B squared plus C squared minus 2BC cosine A. So C squared must be A squared plus B squared minus 2AB cosine C. In other words, going back to this one, if you want to find A, over here we have something other than A, over here something other than A, the same thing here. The only thing is this is the cosine goes back to A. So that's why cosine C goes back to C. Okay, that's how you do that. All you have to do, plug in, you're done. So we have 2 squared plus 3 squared minus 2 times A times B times cosine of 60 degrees. So 2 times A times B cosine of C, cosine of 60 degrees. And cosine of 60 degrees, we know it to be 1/2. So one of the 2's go away, and this becomes a 4. No, maybe they use a different color. 4 plus 9 minus just 2 times 3, 6, which gives you 7. So C is square root of 7, because that was C squared. So we got this side. So we have all sides. Now we can find the rest of it either by cosine law or sine law. Okay, because we have all sides and one angle, we can use the sine law if we want. However, if we want to stick with cosine law, we can use this formula. So cosine of A is B squared plus C squared minus A squared over 2BC. So we plug in the B, C, and A. B is 3, C is 2, and A, actually we want the squared one, so 7. So this is 9 plus 7 plus C squared. 7 minus A squared, which is 4 over 2 times B which is 3, and c, which is square root of 7. So 7 minus 4, 3, and 9 is 12. This is a 6, and they cancel each other. They give us 2 square root of 2 over square root of 7. Let me just first make sure we understand that this one is 2 over square root of 7. And if I multiply by square root of 7 over 7, I get 2 square root of 7 over 7. Now, we want a class, we want a, so a is cosine inverse of that. And at this point, you have to put it into a calculator, and it ends up being 40.9. So again, you write this, which is an exact answer. This comes from a calculator. And now that we have two angles, we have this one, we have this one, add them up, subtract from 180. 79.1 degrees. This is almost 80 degrees. So again, please understand right here, you have to use a calculator. So we got 79.1 degrees here. All right, here's another example. Using cosine law, we want to solve the triangle. Side angle side, A is 4, B is 3, and C is 6. Actually, it's all sides, everybody. Okay, so it's all sides. All right, so we need to use this formula to find one of the angles. After we find one angle, then we can continue with the process or go with the sine, either way. So using this formula, just plug in. Using this formula, just plug in. Okay, B is 3 squared, C is 6 squared, minus A is 4 squared, and 2 times B, 3, C is 6. So this is 936 minus 16. So the numerator is 29. The denominator is 2 times 3 times 6, 36. And so what is A? Cosine inverse of 29 over 36 precisely. Using a calculator, and maybe one decimal, we get one of them. So A is 36.3 degrees. A is 36.3 degrees. 36.3 degrees. What about B? We use the same formula. Now, if I change this to B, okay, we can even work it out here. If it's this is B squared, what happens to the rest of it, okay? So if you change this to B, you get A squared plus C squared minus B squared. Notice for A, we use A squared here, right? So for B, we use B squared here, and we don't have it down here. So down here must be 2AC. And so 1636 minus 9 becomes 43. The denominator 2 times 4, 8 times 6, 48. So B is cosine inverse of this number. B is cosine inverse of this number. Using a calculator, we find the B to be 26.4 degrees. We put it in there. Now we have two of them. The last one, all we have to do, add up the two, subtract it from 180. So to find the last missing angle, 180 minus these two. So C is 180 minus A minus B, or minus the parentheses A plus B. So in essence, add up these two and subtract it from 180. You get 117.3 degrees. And that's the last missing angle. Again, when we find one angle, then over here we have a choice of using sine law or cosine law. That's why sometimes we mix them up. All right, let's look at the application. Could somebody read this for us, please? I appreciate that.
A boat leaves Naples for Key West, 150 miles away at 15 miles per hour. It encounters heavy crosswinds and strong currents. The crew finds, after 4 hours, that the sailboat is off course by 20 degrees. A. How far is the sailboat from Key West at this time? Side X equals question mark.
Excellent. Thank you so much. So in other words, if you look at the setting is given, okay? So we want to go from Naples to Key West, from one point to the next. We are off by, and that distance is 150 miles. So this distance is 150 miles. We are off by 20 degrees. So we notice that after 4 hours, why is this side 60? It's 4 times 15 miles per hour. So I want to make sure we understand this. Let me. So this is because 15 times 4. So this distance is 60. This distance is 150. This angle is 20 degrees. And what we want to find, how far is the sailboat from the Key West? So we want to know how far we are from the Key West, which is eczema. So we are finding the side X. So what do we have? We have this side, and the included angle. So we are going to use a squared equals b squared plus c squared minus 2bc cosine a. So because we want this one is x squared, one side is 60 squared, one side is 150 squared, so 150 squared plus 60 squared, minus 2 times bc cosine a minus the product of these two numbers, 150 and 60, and cosine of 20 degrees. So this is the triangle that we are using. So we are using this as 60, this as 150, this angle of 20 degrees. This is the side X that we are finding. So just plug in. I'm gonna leave it for you to plug this into a calculator. That's all. When we plug it into a calculator, x squared becomes 9,185.53. So what is x? You take a square root of that. So again, this is x squared. What is x? You take a square root of that and it becomes 95.8, almost 96 moles, depending upon what they ask you. For this one, it's close enough to 96 moles. And all of this is approximation, by the way, and it's okay. But however many decimals they ask you to use. So x is the green side. So x is 95.8 or 96 miles. Through what angle should the sailboat turn to correct its course? So we want to go this way, but we are going this way. So we have to make this turn. We have to find the angle A, everybody. So again, what do we want to find? Angle A. And then angle theta to get to angle theta. So the turn that it makes, we are interested in finding this theta, but we can find A from the information either using cosine law, or cosine of A equals B squared plus C squared minus S squared over TBC. So we can find A, and I hope you see that theta and A, they add up to 180. So if we continue in this direction, that makes a 180-degree angle, right? That's a straight angle. So if this is A, theta would be whatever A is subtracted from 180. So A is a question mark and theta is 180 minus A. So what are we looking for theta? How do we find theta? First, we have to find A. Continuing with the cosine law, to find A, because we have all sides, and again, you can even use the sine law. We're going to stick with the cosine law because of the section. So we can say this side squared, 150 squared, is this side squared, 95.8 squared, plus this side squared, 60 squared, then minus the product of these two sides, x and 60, which is minus 2, 95.8 times 60, and then cosine of A. So we're going to use that. And basically, you square this one, you square this one, you square this one, and you add this to subtract it from 150 squared. It equals to minus 2 times 95.8 times 60. So this becomes 9684. In other words, just do the math. Move this 2 to the left. Divide by negative 11,520, and cosine A becomes negative 0.8406. So divide by minus 11,520, and cosine A becomes negative 0.8406. Putting it into a calculator results in A being 147.2. What do we want? We want the value of theta. And theta is what? 180 minus this number, which gives us 32.8. Therefore, we found theta to be 32.8 degrees. So we're going this way. We had to make the turn. This is the angle they were asked, theta. How much time has been added to the trip because of this. Assume that the speed is not changing. It's 15 miles per hour. Well, let's see how much we were supposed to cover 150 miles. How much did we cover? 60 plus x, which is 95.8 or roughly 96. So this one plus this one minus this one is the extra mileage. So added distance is this plus this minus 150, right? So let's say 60 plus 96 minus 150, and we have added 6 miles. If we are doing 15 miles per hour, okay, T is D over R. Remember, D equals RT from elementary algebra. D equals RT. T is D over R. 6 divided by 15 is the added amount, 6 over 15 hours, which is 0.4 hours or 24 minutes. And by the way, all you have to do 0.4 times 60, right, to get the minutes. So class, just replace the H with 60. 60 times 0.4 gives you 24 minutes. I think it's clear to everybody. Okay. So that's, let me just write that. If you replace this with 60 minutes, you get 24 minutes. The product is 24 minutes. Could somebody read this, please?
An airplane fly due north from
Fort.
Fort Myers to Sarasota, a distance of 150 miles, and then turn through an angle of 50 degrees and fly to Orlando, a distance of 100 miles. A, how far is it directly from Fort Myers to Orlando?
Thank you so much. All right, let's see what we have and what we need to do. So this distance is 150 miles. We turn 50 degrees and we cover 100 miles to get to Orlando. And we want to find the distance from Fort Myers to Orlando. Just take a look at this train. So this is 150. This is 100, and we don't know the mileage from here. So 150 miles, 100 miles. But we do know this angle is 50 degrees, which makes this angle 130 degrees. So we call this lowercase a. We call this angle A. And angle A is missing this angle. Let me. This is angle A. And because this one is 50 degrees, angle A is 180 minus that. So it's easily found. And now we use A squared equals B squared plus C squared minus 2BC cosine A. So A squared is 150 squared. So we use that formula. Okay, so this one is 130 degrees, everybody. And we're going to use the cosine law. So A squared is 150 squared plus 100 squared minus 2BC cosine A minus 2 times 150 times 100 times cosine of 130. Plug in, find A squared, then take a root. So I'm going to leave it for everybody to finish that. This requires Of course, especially cosine of 130 requires a calculator. This doesn't need it. This is 225 and add two zeros because 15 squared is 30. So this is easy to calculate. So this is 15 squared is 225 and two zeros, 100 now has four zeros, and then you do the rest. But this one requires a calculator, and you take a root, A becomes 227.56 miles. What bearing should the pilot use to fly directly from Fort Myers to Orlando? What bearing? Well, north. First of all, let's create an angle here. We call it B, which is missing. So north, this angle B, east. North, this angle B, east. So all we have to do, find the angle B. That's the bearing. North, B degrees east. So we can use either the cosine law or the sine law. Either way makes no difference, everybody. So if we want to stick with the cosine law, we can use that. Since we want this one, this is the side that we have. So 100 squared is 150 squared plus A squared, which is 227.56 squared, minus 2 times 150 times A, which is this number, 227.56A. 227.56, and then cosine of the included angle, cosine B. We can use the cosine law, or which in essence is using this formula. You can use that formula. Or we can use the sine law. So the ratio of sine B to the opposite side, 100, is the ratio of sine A, or 130 degrees, to the side A. We can use that one. And that's what I mean. When you are using the cosine law for some part of it, you may be able to use sine law. It doesn't matter. And either one you saw, for example, here, if you do the cross product as an example, this means sine B is 100. Sine of 130 degrees over 227.56. Then you use the sine inverse on your calculator, and it gives you the angle 19.7 degrees. So this is a north, 19.7 degrees east. Again, as far as the calculation, you can use any of them, and I leave it for you to finish the calculation. It's very straightforward, everyone. Could somebody read this, please?
Flying from Chicago to Louisville, 330 miles, a pilot carelessly took a course that was 10 degrees in air. if the aircraft maintains an average speed of 220 miles per hour, and if the error in the direction is discovered after 15 minutes, through what angle should the pilot turn to head toward Louisville?
Excellent, thanks. So look at the setting. Either the setting is given or you have to make it up. So this is the distance of 330 miles. Making a mistake with a 10-degree in error. We are going this way. And we are going with the speed of 220 miles per hour. We are going in this direction. And again, this may not be to scale by any means, everybody. After 15 minutes, we notice what's going on. And then we detected the error and we are trying to fix everything. So here's the angle B, everybody. And here's the angle that we are going to use to adjust it. And clearly, whatever this angle is, which we don't know, this one will be the supplementary angle, 180 minus B. So we are looking for this angle. We are looking for this angle, which we don't know. So if we find this one, which we are going to call it angle B, this will be 180 minus B. So let's find angle B, and then the angle of interest is the supplementary angle because this is a straight angle. They add up to 180 degrees. All right, so we have this side, we have this angle. We don't have this side, but we know how to find that because D equals RT. And if we call this distance C, using D equals RT, the rate, the speed, the average speed is 220 miles per hour. And the time is 15 minutes. So I'm going to write 15 over 60. Everybody knows 15 over 60 is 1/4. But on purpose, I want to keep it as 15 over 60 so everybody can see why it's 1/4. 15 minutes. But this is 220 miles per hour. So 15 minutes is 15 over 60 hours or 1/4. So this is in hours or 1/4. And 1/4 of 220 is 55 miles. So the distance of C is 55 miles, which means we have this side, we have this side, and we have the included angle, which is 10 degrees. And we can find the missing side. We can find this side also. A squared equals B squared plus C squared minus 2BC cosine A. That's the one we are going to use. We're going to call this A, everybody. And so A squared is one side, 330 squared, plus the other side, 55 miles squared, minus 2 times the product of these two numbers, and then cosine of 10 degrees. So 330 squared plus 55 squared minus 2 times 330 times 55 times cosine 10. This is the cosine law. Now again, you put it into a calculator and the right side becomes a number. Because cosine 10 is not a common arc, you have to use a calculator. Whatever the answer is, you take a root, and A, of course, the positive one, A becomes 276 miles. Again, roughly. Since this is given as 330, we want to go with just a whole number. Now we have all sides. We can use either the cosine law or the sine law to find this angle B. So to find this angle B, we have several choices. And because this is cosine law, we're going to stick with the cosine law. We're going to follow that. And we are going to say, since this is the included angle for these two, we're going to say this side squared, 330 squared, is this side squared, 55 squared, plus this side squared, which was 276 squared, minus 2 times the product of these two, 55 and 276, and cosine B. So we have all sides. A is 276 miles, B is 330 miles, C is 55 miles. All we have to do, find angle B. Find angle B, and that's exactly what we are going to do. Again, putting it into a calculator, you can find cosine B, and then the inverse function, you find B. So there are maybe 1 or 2 steps here left. I highly recommend you fill in these steps because the rest is just using a calculator. So raise this to the second power, this one to the second power, this one to the second power, multiply these two, and then times cosine B. So move this one to the other side, this one to the other side, divide by -2 times 276 times 55 becomes cosine B, and then B is the inverse of it. So if B is 168 degrees, the angle we want is 180 minus that, or 12 degrees. So this is 168 degrees, and we found what we want to be 12 degrees. So this is 12 degrees. What new average speed is needed to keep the total time of trip at 90 minutes? So we want to make it, we were supposed to make it, I guess, from here to here in 90 minutes. Now that we've gone this far, we're going to go a little bit more. So how do we make this into a total of 90 minutes? We have already covered 15 minutes, everybody. So how many minutes we have left? We have only 90 minus 15, or 75 minutes. And 75 minutes is 1.25 hours, because 75 minutes is 60 plus 15, and 15 is 1/4 or 0.25 hours. Why are we going with the hours? Because the speed is 220 miles per hour, and therefore we are going to go with the D equals RT, and we are going to find the rate now, because it was 220 miles per hour. Now it's going to be a little bit more. So the rate is D over T, D over T, D over T. So what is the distance we're going to cover? The distance is this distance A, which is 276 miles, and the time is 1.25. You're putting it into a calculator, it becomes 220.8 miles per hour. So if we do a little bit more, so if we did 220 miles per hour, probably it takes 92 minutes or 91 minutes, or we can calculate it. But if we go a little bit faster, 220.8 miles, almost 221 miles. In fact, if we make it 221 miles, we make it before the 90 minutes, just slightly. Last question. Could somebody read that, please?
A radio radio tower 500 feet high is located on the side of a hill with an inclination to the horizontal of 5 degrees. How long should two guy wires be if they are to connect to the top of the tower and be secured at 2 points 100 feet directly above and directly below the base of the tower?
Excellent. So to understand this, let's do the drawing. Okay. So we are saying that this distance is 100 feet. So is this distance. Okay. And we say this is 500 feet. And this inclination gives us 5 degrees. So this is the same setup. So this distance is 500 feet. This distance we want to calculate, we don't have it, we call it x. This distance we want to calculate, we don't have it, is y. We know this distance is 100, this distance is 100, and this angle is 5 degrees, everybody. This angle is 5 degrees. So if you continue with this line, and this is 5 degrees, this angle, class, remember this is a right triangle. So make it bigger, make it looking like that, this one. This is 5 degrees. This is 90 degrees. What should this one be? This angle should be, everybody?
85.
85. So this should be 85 because they have to add up to 90 degrees. So we have this angle, 85. Now, what should this angle be, everybody? What should this angle be? If you go through, let me just
95.
actually say it again.
95.
Perfect. So this is 85. This is 180. So this must be 95 degrees. Let me just actually clean this up and do it again so it becomes clear to everybody what we're doing. So this must be 95 degrees. Again, this is not too scary. What should this one be, everybody? You can say 180 minus 95, or you can say must be the same as this one. Either one becomes 85. So take a look. This is 85, this is 95, and this is 85. So we have the angles we need. If we look at this side, x squared is 100 squared plus 500 squared. So first of all, using the cosine law, so x squared is 500 squared plus 100 squared minus 2 times the product of these two and cosine of 85 degrees. So again, let me just shade the region. So we are looking at this one, everybody. To find x, look at this one. Put it into a calculator, you get x squared, take a root, and it gives you x. This one, the blue one, everybody. The blue shaded triangle. We want y squared, which is 500 squared plus 100 squared minus 2 times the product of these two, 500 and 100, and cosine of 95 degrees. Put it into a calculator, do the job, gives you y squared, take a root, and it gives you the y value. So in short, cosine law says a squared equals b squared plus c squared minus 2bc cosine a. This is the included angle. This lowercase a, this capital A must agree. And if you solve for cosine a, it results in b squared plus c squared minus a squared over 2bc. This is the cosine law.